This is House Planning Help episode 85. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in building better housing. Whether it's brand new or renovation projects, I'm exploring what houses we should be building in the 21st century. My personal goal is to create an energy efficient home before I turn 40 in August 2016. Coming up in this session, my guest is Sofie Pelsmakers, environmental architect and doctoral researcher at UCL Energy Institute. That stands for University College London. In case you're out of the loop, this is quite a special place actually, so very happy to have Sofie on this podcast, and she's going to share 10 environmental design myths. This also ties in quite nicely with her book too, which we'll explain more about very, very soon. After today's interview, what I wanted to do was look at some feedback from our documentary, The Future of Housing and How Airtightness Can Help. I've shown it in a number of different locations, London, Glasgow, Sydney, Melbourne, hoping to do some more as the year goes on. It's also had a screening in New Zealand. A big thank you to Elron Burrell for introducing that at the South Pacific Passive House Conference. And the comments that we've had are both good and bad. As you might expect, a lot of the time you're going to get mixed feedback. However, I have nothing to hide. And if anything, I thought it might be quite constructive if we look at what those comments are. So we're going to do that later in the podcast, which is why we need to get cracking with today's interview. Sofie Pelsmakers has recently released the second edition of the Environmental Design Pocketbook. Although it's aimed primarily at architects and architecture students, that doesn't mean that there's not a lot that we can all take from it. So Sofie has put together a list of 10 environmental design myths, and we're going to explore those now. I started my conversation by asking her to tell us a little bit more about herself.
So I'm trained as an architect, and I worked in practice for over 10 years and was also teaching at university. And I just realised that people always have the same questions over and over again. And so that's, I got pretty annoyed that we didn't have one source that have all of the information in it. So that I ended up writing the book with the idea that I could use it in practice, use it as a syllabus for students to say, go to that one and it'll tell you where else you have to find the information. And so, so I'm just very passionate about contextual design. I couldn't design any other way. And it's all about minimizing our impact on the planet. And I just found that there's a lot of information out there that just tended to confuse a lot of people in practice and at universities. And I just wanted to dispel some of the myths and give the information out that is useful to people in practice and when they're studying.
And you've given me 10 environmental design myths to look at today. I'm quite intrigued because they're all very different. And let's just dive straight in. You can tell me all about this. But the first one you've put is climate change is in the future.
Yes, I mean, there is a notion that, and this is obviously a myth, climate change is already happening. There's a notion that we're always working towards, this might be happening in the future if we don't design better buildings today, if we don't actually cut our energy use, if we don't actually, at all the industry levels, cut our carbon emissions. And actually what's happening is that climate change is already here. If you look at some of the data from the Met Office, from NASA, all the warmest years have all been in the last decade. Warmest summers have all been in the last decade. Again, 2014 was considered the warmest kind of year globally on record. And of course, last year we had mega floods in the UK. So we are already witnessing some of these predictions that have been made 10 and 20 years ago about more extreme weather events, greater occurrence of hot summers, greater storms, and for example, and also these flood events that are associated with it. So this notion that we're designing for this distant future is actually really wrong. We're already facing some of that. And of course, it's only going to increase either in intensity or in occurrence. And I do think that makes a difference to how we approach our clients or how we inform our clients and the public about what is happening, but also our own duty as designers. How do we make sure that buildings that we know will be standing by 2050, 2080, still perform up to the standard that they were designed for and that they're fit for purpose? And I think that's a very interesting question academically, but a very pertinent one from a social point of view and a cultural point of view. We need to have buildings that are safe to be occupied then and not to be demolished further down the line.
unless they were designed to be demolished. Could that be another approach to it?
I mean, yes, there's quite a lot of work going on, sort of designed for deconstruction. So that means that if they need to be demolished, that components can actually be reclaimed, recycled, or reused again. But still, none of that is ideal. You know, ideally, we actually design buildings that either take into account the future changing climate or that can actually be adapted further along the line in the future. And my view is that a lot of the issues that we need to do today for, say, for our climate in the UK, which tends to be cold winters, we have to minimise heat loss from the building fabric. Those strategies that we need, which is good insulation, super insulation I would call it, good air tightness, they're the same strategies that you need to reduce overheating in summer. Now, of course, you then have to make sure that that is alongside solar design and solar shading. You know, I always get worked up when people say, oh, it's well-insulated buildings that overheat, when ultimately it's not well-insulated or insulation that makes buildings overheat. It's a well-insulated building with bad solar design, you know, where too much sun comes in the summer and there's no solar shading opportunities. Now, some of that can already be designed for today, for particularly these events that will occur more often in these hot summers, but also to allow for that to be added in the future.
Looking at these points on your list as well, are we saying that a lot of designers, architects aren't really taking this in? For example, if we move on to the next one, what if global warming is not as bad as predicted?
Well, I'll take the first part. I do think that there is actually the good architects are taking this into account. They're very aware of it and it's part of how they design. And I do think Bill Gething's book, Designing for a Changing Climate, I think it's called, is quite seminal in that because this TSB project funded architects and engineers to look at how can you include some of this, how do you model some of that? And it's sort of, you know, you can use already existing models and data that we have and future climate data to actually see how the building might perform, and it's sort of this robustness check, if you like. You know, it doesn't mean that this is what will happen in reality in the long term, but it does give you a good view of what does happen or might happen when this building is actually facing very different environmental conditions. And that's actually very, very telling. And I know that a lot of the good architects are doing some of that work behind the scenes. Unfortunately, clients are reluctant often to pay for that because it is extra work. There should be extra fees involved in that. And so I think that there's an issue there. But I think we need to remind ourselves about this aspect of global warming if it's not as bad as predicted. So if it is as bad, global warming, you know, climate change as we think it is, then we might see fewer winter deaths from cold, but we probably will get greater summer deaths from overheating and stress on the human body and from buildings, living and working in buildings that are actually not fit for purpose in those conditions in the UK unless we adapt them. So actually, currently it seems that the offset in health issues from fewer issues in winter is not going to help us from summer. So there are these issues that we're facing. Likewise, flooding, you know, will cost billions of pounds in economic losses when buildings are flooded, let alone personal losses and psychological impacts on people when that happens. And then, of course, health impacts as well. So we can't really put numbers on that. And my take always is, if we're wrong about climate change, if things aren't going to be as dire as predicted, what it is, I'm hoping this is the case because currently we're not doing enough to avert it and we're not doing enough to adapt our buildings. But if that is the case, then really what is the worst that can happen? Well, then we've actually designed buildings that are decent, good, perform, function in this climate and in any future. And we've basically made a better world and better buildings for everyone at any time, for no reason. But that's still a good outcome, I would say. So I think there's no losses there from adapting buildings and designing good buildings with the future in mind. And in a way, the worst case future in mind.
Let's move on to the third point. We've touched on this on our topic before, but you've put green roofs. Are they green, right?
Well, there is sort of a fashion at the moment whereby if a building looks green, for example, it's got renewables on it, green roofs, green walls, which is one of the other myths I've got in here, that it must be green, right? And my point is that, well, actually, it depends what kind of green roof and in which part of the country and how well shaded or protected or unshaded it is in that part of the country. And so it comes back to this issue that one solution or one technique isn't necessarily suitable for all the situations in different regions in the UK or across Europe. And particularly with green roofs, you've got extensive, very thin roofs that you can't walk on, where usually the sedum is imported from places like Germany. If it isn't, you need to actually order the materials of the sedum well in advance to get it locally, something like 18 months, so you can reduce its environmental impact. But there is an environmental impact associated with this because a lot of it is imported. And then if you place these thin roofs, for example, in the southeast of England, in one of these drought periods, you will just have the sedum die off. And then clients are not happy, then people are starting to look at replacing them, which is additional costs. And again, additional embodied energy from these plants that you basically were slowly killing by putting them in the wrong position. So it really depends on what kind of green roof you put where. For example, in the southeast, you're much better at putting deeper, intensive green roofs or biodiverse and brown roofs where local plants can grow and there's a thicker layer of soil so that it can absorb more water and hold more water in cases of drought. Of course, you can still collect rainwater from these roofs, and you can argue that in areas of, drier areas of the UK, that perhaps you don't want that to be retained at the roof, but you want it to be going back into the geological cycle. So there's other issues there as well. So it's not as simple as it seems, basically, and we need to be more careful about how we apply these systems across buildings.
Nothing is as simple as it seems. So, are you linking these two together a bit? Because green walls is something that I've never looked at. I like the feel of it, but tell us what's wrong. Is it just because we're talking about something that's vertical that really just shouldn't be vertical?
Well, you've got, again, different kinds of green walls. And I do agree with you. There's something really nice, particularly in built-up areas, to have greenery that we sort of can touch and we're close to. The problem with the green wall systems that are currently quite fashionable and used a lot are vertical systems, or I should maybe say horizontal systems, because they require the roots of the plants to grow horizontally. They get put into small pockets of sort of woolen fabric. And what we then have is that we have a massive amount of energy gets used to circulate water and nutrients around these plants to feed them. And this is pretty much 24/7. Now, a lot of these systems that I've looked at, they failed. They failed because the system is either not maintained, so the plants don't get watered or don't get the nutrients they need, which then means the plants die. Or they're in very exposed areas along rivers, for example, in Paris. Some of the plants are also tropical, imported from thousands of miles away across the world. And so none of them are really suitable to grow in those conditions, which means that then we're forever spending money and resources and energy to keep them alive, and if they die, to replace them. It just seems insane when we should just be growing plants from the ground up on long trellising or along buildings, and this can also be done beautifully. It's just that we won't get an instant green wall. It will take time for these plants to grow up and find their way, but it's a much more robust way of doing it.
It does seem that an overall theme of everything that we've got to do into the future is simplicity. It's about going back to how things were done and taking a simple approach, not something that's overly complex.
Yes, I think there's definitely something about that we're sort of either trying to reinvent the wheel or we try to make everything very innovative and special when actually people may have tried certain things already 20 years ago. Then we've forgotten about it and then we're trying it now again and it doesn't work. And I think there is a real danger in sustainable design that we're going towards the gimmicky, which kind of brings us to the next myth, I think, which is about micro-renewables such as micro-wind turbines, that they're not really appropriate to put onto buildings, but often they make a building look green. Look, I'm kind of stating how green I am. I care about the environment, but actually you could be doing... well, you might be doing more damage than good. The BRE found that the energy that goes into making the turbine and getting it onto site could actually be greater than the energy you ever get from the wind turbine, particularly when you put them on buildings in urban areas where there's just not enough consistent wind to create, sufficient energy. So it's those kind of issues that we have a lot of technology, just how we apply it, we have to be incredibly careful about and steer away from bolt-on measures and gimmicky kind of solutions.
And quite often the case, as I've seen a picture in the PDF that we're hoping to run alongside this, you have these buildings where actually they switch off the renewables because, I'm thinking of a turbine here, it's too noisy.
Yes, I mean, absolutely. I mean, there's obviously implications of this. We're not used to it. We don't know necessarily the effects. So millions of pounds are spent on renewables in and around buildings. And then there's these unintended consequences, which we're finding a lot of. And this is one example whereby basically, wind turbines catch the sun, they flicker, they make some kind of noise. We're not used to that. So people complain and they're switched off. And then, of course, at that point, we've spent millions and have completely no renewable energy anyway. It's quite complex. But I think if we step back to the basics, which is sort of what you were saying earlier on, then I think actually we don't make our lives as complex as they need to be.
The next one that you've got on your list is grey water and rainwater harvesting. Is it always environmentally sound, is the question you pose?
Well, again, that's the issue, isn't it? If you want to just be concerned about water and saving water, then, of course, installing grey water and rainwater harvesting systems will do exactly that for you. But then, depending on the kind of system that you use, you could end up actually saving very little water for a great energy cost. To give you an example, if you've got a large building, quite complex, several units, for example, housing units or offices, and you collect water, for example, from the roof, you probably will need to store it below ground or in the basement, and then you need energy to pump this back up, for other purposes. Often rainwater gets used for example, for toilet flushing, and I would argue that actually the rainwater is of too high quality to just flush toilets with. Ideally, you wash clothes with it or you use it for irrigation of landscape, for example. And similar issues, of course, also with grey water recycling, so where we catch water from basins and baths and showers, and we basically clean it. That can be done, or is often done chemically, and then the water needs to be pumped around again to provide then water for flushing of toilets. Now, that's a good use of already used water to flush toilets because the quality isn't as great. But the problem with it is you need dual pipework in all of these systems, because if you have not enough rainwater or grey water, you need another supply still, which is the mains, which means that the embodied energy massively increases in these systems. A lot of it is steel, plastic, pipework. So it does mean that actually the embodied energy is quite high in these systems. And on top of that, you also have some chemical cleaning components. So ideally, the way we would do grey water and rainwater harvesting would effectively be very localized and using gravity-fed systems. So you just collect stuff, leave it in the roof, and then by gravity, it just can get used. And also what we call kind of short retention recycling, so that the cleaning doesn't have to happen biomechanically, but small amounts of water can stay, for example, in a system and immediately get reused. So there's no need to worry as much about bacteria and other buildups in that water. But a lot of people don't know this. We think, we've got a grey water recycling system, we're providing a green system, when actually, yes, we're saving some water, but a great environmental, particularly embodied energy and embodied carbon cost when we do so. So they are definitely issues. And the other thing, which brings me to the kind of seventh myth, is the fact that we also think when we apply eco measures that will always save money, that will reduce bills. But of course, for example, if you've got systems like grey water recycling systems, you actually spend more energy pumping the water around, cleaning the water, feeding that water back, than actually just using the mains water. So your bills would increase in that case.
I've got a question here, because this is the issue, isn't it? That so many people want to do the right thing. And I find this even in the podcast, that you can interview one person and they'll say one thing, and you can interview someone else and they'll contradict what you've already heard. So how, as the person wanting to do the right thing, can we make sure that we get as close to that as possible?
You got to get my book.
Trust?
You got to get my book. No, that's a terrible plug. No, I think you're absolutely right. Of course, also our field moves so fast. So sometimes, for example, we try one thing in a building, and almost a building on its own is, if you like, a prototype. We're not like manufacturing of cars, whereby thousands are produced. The first ones are all tested and they go through this rigorous process. If you like, each building is almost its own prototype. And we actually suffer then from these unintended
consequences. But a lot of these new buildings are terrible. At least with cars, they're driving things forwards. But we know a lot of buildings are just put up so that it can be sold for money.
Yes, and I do think that we're not ambitious enough from a legislation point of view, from the government as well. I think they can do a lot more to drive some of that innovation and these requirements. But unfortunately, there's a very strong lobby whereby industry is saying we're not ready, this is going to cost too much money, we won't be able to then build the housing that we need to, which we're not doing anyway. And it means that a lot of the proposals are then watered down. Also, research-wise, there's been a huge gap in research between pretty much the 80s and late 90s up until maybe 5 years ago. So for 20 years, there was almost no research going into how buildings really perform, what are the best solutions. So a lot of what we're doing now, somebody's already looked at some time ago at an older system, and then we're finding out today that actually solutions aren't quite what we thought they were. And I think the other thing is, and somebody from Hawara Lee mentioned this in the February SIPSI journal as well, that there are real issues, a knowledge gap, if you like, between getting the information of academia and practices who do this work out into the broader industry. And there is a real issue whereby we somehow aren't able to get this out to the bigger domain so that everybody is aware of these findings and can build on those rather than make the same mistakes again. I do think that the Passive House Trust, the Good Homes Alliance, they're very good at, for example, sharing a lot of that work and that research across the kind of wider public. And I think there's a lot of good stuff happening there. But we need to do a lot more of this and at all sorts of different levels of technology to material use and detailing. And I completely agree with you. Too much mediocre stuff is built and we're still not quite sure what is right or not. And again, one thing could be right in one situation, not in another. So it could be that everybody's right or everybody's wrong. But it makes it quite complex from that point of view.
Number 8 is, does a zero energy building mean its environmental impact is zero?
Well, very quickly, no, because currently zero energy building means we're just looking at the energy used in the building. And for example, with the current definition of a zero carbon building in the UK, you'd actually, and we're still waiting for confirmation of exactly what it will entail, but you'd actually have to build at such low density levels, less than the average of England, at about 30 dwellings per hectare, that this means that you can no longer support public transport efficiently. It will just be too expensive to run trains and buses because the population density is too low. Schools will be located further away, shops, etc., which effectively means that everybody will be commuting by car. So even if you live in a zero energy building, if then you end up having to commute by car and using fossil fuels to do that, your impact would be quite significant, actually. Just briefly on the previous point about eco measures and energy savings, there's another thing as well about unintended consequences, which is basically that we think measures would save energy, but actually in a lot of cases people might behave differently, particularly for refurbishment of buildings, for example. It's what we call take back. And so there are issues there as well on that point. But yes, on the zero energy building, I think it's a shame that we're not looking at it more holistically, and that this is so difficult to provide energy from renewables on site, and that as soon as you have to look at that, you're looking at building a lot less dense, or you're looking at technologies that are also limiting, such as biomass boilers, for example.
I know I'm rushing you through these, but it's okay. There's the book. Number 9 is, if I have clean, renewable energy, it doesn't matter how much I use.
Yeah, I think this is a common myth, actually. A lot of researchers particularly will say this related to the existing housing stock. So we've got about 27 million buildings in the UK. They're built to pretty appalling standards, often because a lot of them are very old, so energy then wasn't an issue. And they're still standing, and they're still going to be standing by 2050. So a lot of people then say, well, we shouldn't worry about upgrading these and reducing their energy use because we just have to decarbonize the grid, and then it doesn't matter how much energy that they use. Now, that's actually really wrong. If we have a high energy demand from buildings, it means that we need a substantial array to decarbonize the grid. So we need a huge number of renewables. This not only costs more, but we should also not forget that a lot of the renewables are made out of steel and other finite resources, that the greater the array of renewables that we need, the greater the embodied energy of making these renewables is. And it also means that if renewables stop working, you actually are back to an energy leaking and energy, demanding building, and it doesn't provide thermal comfort to the occupants. And if, for example, on-site renewables fail and the resident cannot afford to replace the renewables, for example, or have them fixed, then the resident wouldn't be able to keep warm. So there's some real issues there. So the first renewable to consider is always energy efficiency before you start looking at renewables who can then provide the remainder, because we simply don't have the resources and the amount of money or space to put this vast array of renewables to meet our current energy demand in buildings.
Finally, and I like this one, because it says retrofit of existing buildings equals unneeded and boring, dispelling this myth that retrofit is boring. I think it's anything if boring.
Well, it depends, doesn't it? I think it's boring from the point of view of a lot of architects.
Really?
Yes. I think a lot of architects like building new buildings because their name is more directly associated with it. While, of course, when you have a retrofit of a building, it means you're retrofitting a building somebody else designed. It's also very complex and complicated, so it actually feels a lot of the time quite unrewarding for the architect, because it feels like they're tinkering at the edges and can't do substantial interventions because of the expense, but also because of the existing structure and all the other limitations of retrofit. As I previously said, there is about 27 million existing buildings in the UK built to a very bad standard, and it's absolutely fundamental that these are upgraded, because without doing that, we have no chance of meeting any of our carbon budgets by 2050. Also, fuel poverty is a big issue. And, thermal comfort to people who live in these buildings. So it's absolutely fundamental that we do. So it's definitely needed. And I would argue, I don't think it's boring. I think actually it brings the architect back to some of the base principles that we often forget, which is, air tightness, thermal bridging, insulation details. Where exactly does the window sit in the frame? How do we deal with, working, for example, with residents who might remain in situ when the works happen? And I think we kind of need to get back to some of that knowledge again that we have long forgotten. And so I think it's definitely not boring, but I think a lot of people think of it that way.
Well, Sophie, I want to thank you for going through these environmental design myths and blowing them out of the water. But I suppose I really want to know why you have done all this, why you've put the book together, and what you hope might come from sharing all this knowledge and investigating a few of these different issues.
Well, aside from the fact that it's actually really good fun doing research in this area and it keeps myself up to date, the real reason is actually to make a change. Architects and self-builders don't have the time to read 30 books and trying to wade through all these arguments. So what I try to do is distill everything in one single source, and then from there it has loads of pointers to other sources, so that if the self-builder or the architect wanted to have more detailed information, it can go directly to that primary source. But it really is to make a change, to make sure that we as architects can spend more time designing and making good architecture that's fundamentally sustainable, rather than spending our time trying to figure out what is sustainable or what isn't effectively.
This list that you put together, obviously the book going into a lot more detail. My question now is about the clients or people like me wanting to build an energy efficient home. What advice would you have for us?
Well, firstly, I would say that there's still a lot of information that's very relevant in my publication. But I would really say that you're in a way the ideal client. If you're wanting to design something environmentally sound, you're the ideal client for many practices. And I think if you inform yourself, you will be able to find the right architect, but also you will also be able to ask uncomfortable questions about, have you actually, or can you model how my house will perform? Because I would like to grow old in it. And so that when you're aware of these things, you can actually ask these questions and really become part of that process and have a very interesting process and own your own dwelling, I guess, and your own house that way, and also make sure that all the things that are in there are actually what you want, and that the trade-offs you make are the trade-offs that you want to make, so that you take some of that control back, if that makes sense.
Sophie, thank you very much.
Thank you, and good luck with the rest of the project.
For me, one of the best parts of doing this podcast is meeting passionate people. And I don't think we're in short supply of those, again, proven to date by Sophie. You can find out more about her in today's show notes at houseplanninghelp.com/85. We've summarised the myths, but also Sophie's given us her downloadable PDF that has lots more details as well. We've got a link to the Environmental Design Pocketbook, and you can follow Sophie on Twitter. She has a great feed, actually. It communicates that passion yet again. So follow her there. All the links in the show notes, houseplanninghelp.com/85. Finally today, I want to reflect on the documentary we produced, The Future of Housing and How Airtightness Can Help. We do lots of video at Regen Media. It tends to be short form for different construction companies. Creating longer programmes is a different skill, and I've worked in television before, but I do not claim to be a documentary expert. Although, luckily, in the production of this, we incorporated a lot of people who have worked in television and got all those skills. So I was very happy with the documentary, but fully aware there's always going to be feedback. I've had people say, it's too long. And then other people say, oh, it's too short. You really should have done it for a full hour. And then we've had some people say, oh, you were a good presenter. And others who said completely the opposite. There's been praise for the fact that it was an excellent snapshot of what's going on in self-build and how the volume house builders have the market cornered. But then criticism that it's been boring and Uncle Bob fell asleep watching the first 5 minutes. I've worked in media for quite a few years now, so don't worry, I'm used to all this stuff. Far more interesting to me was the feedback about what we were trying to communicate. That idea that airtightness, most people don't know. Even if you say draft-free houses, they have no understanding of what it really means and how it all works. And so we wanted to demystify that. Here are a few points. There are lots that I could mention, but just 5. And the first one is actually one that we amended quite quickly. Grove Cottage was an Enefit retrofit. So this is the Passive House standard. Their retrofit standard is called Enefit. And in the voiceover, this is just a careless one where I perhaps insinuated that it's very expensive to do a retrofit. I still have concerns about the expense of doing it, because if it was cheap and that valuable, then lots of people would be doing it. But yeah, careless mistake of writing. It may have cost a fortune. So we just amended that line. Other things that perhaps we could have done, but you could just go on and on doing this, so I don't intend to go back to that. I'm just going to say lessons learnt from this point in. We had a sequence where we took a 1950s house and we brought in the Gunge brothers to use foams and sealants to improve the airtightness, which they did, and that was the demonstration that we were showing improving the airtightness. However, when I was up in Glasgow, of course, what I didn't know is there were some indoor air quality researchers in the audience who really picked me up on that afterwards. Matt, who organised this event, he will know this as well. It was just, and I totally understand it too, because I know that we did a podcast on the making of the documentary, and I brought this up with Paul. Is it really good that we're using foams and sealants? So there's a definite balance. We would never ever want to suggest that you just seal up a home and that's the end of the story. Of course, there are things like ventilation, and that's one reason why I was keen in the documentary to push Enefit and the Passive House standard, because I believe that they've thought out everything that could potentially go wrong, and that's why I like those, because it's come from science and the research has gone in. So perhaps that's just one that we should chalk up, that we need to do a podcast on off-gassing and effects on air quality of making a house airtight and chemicals in the home. One for the future. Yeah, that's on my ideas list. This was a comment that we got out in Australia that's presumably one of the architects didn't particularly like any of the exemplar homes that we used as those key examples. So just passing that on, I don't really know what else to comment on that. I had this a couple of times. People think that I should have pushed things further when I interviewed the representative from the Home Builders Federation. He was defending the energy efficiency of volume built houses. And I understand that to a degree. If I was someone who's deep into getting all political and getting right down to the crux of it. But in a way, I just feel that he said enough. He said enough. It's just my style. I don't want to be that person who's at someone's throat. What if I have to interview him next time? And I think that corporate attitude, I believe that it says it all. So that's that point that I'm leaving behind. And this one's quite a funny one, because at the end of the documentary, I say, right, we've done all this, blah, 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 blah. All I need to do now is find a plot of land and a good builder. And the number of architects who've come up to me and said, So you think it's important to find a builder but not an architect? I was not insinuating this at all. Again, perhaps it was a slight error. I know that architects are essential in this process, and I would fully recommend that you have an architect. Don't just try and build it yourself or not get that expertise. It was just a throwaway line. If ever you make a documentary, don't do this in the end. You get to the end and then you just do a throwaway line. Think very carefully. We did think carefully about it, but not carefully enough. Anyway, if you want to find out more about the documentary, perhaps you haven't seen it yet, houseplanninghelp.com/future of housing overview. And that just goes through it. Maybe you don't want to watch the documentary, but you want to find out more about it. It's got all the links. Perhaps you want to download it in HD. That's all on there. houseplanninghelp.com/future of housing overview. Next time, my guest is Dylan Lamar from Green Hammer. We're going to be looking at how you can visualise your new home before it's built. So we'll be going through some of the processes, the tools, and even pieces of software. That's next time. I hope you can join me then. Thanks for listening.